Okay. All right. It's 1 o'clock. We are going to get started. So welcome to our webinar on smart fabrications in STEAM, easy and engaging projects for educators. We are doing this in collaboration with Xtool. I am Gail with Robot Academy, and we are the educational providers for Xtool and MakeBlock. So we're going to show you exciting things on how to use both the robotics from MakeBlock and what you've cut from our laser cutters from Xtool in order to do some exciting projects for the classroom. Again, I'm Gail with Robot Academy, and we have Ed on here from Robot Academy as well. We have been in business for almost 20 years. We got started in 2006, and we have just had a blast just turning out a lot of really smart kids into prominent engineers and scientists around the country, around the United States, and some out around the world. And so our mission is to help students and educators in the US gain proficiency and confidence with STEM. So we have all kinds of experience getting kids excited about STEM, and we like to pass that on to you. So we're the fun, we make your teachers into the fun teachers that, the kids look forward to your class and be able to do really cool hands-on projects. So we provide a turnkey curriculum to make it easy for you with video curriculum. And we also provide robots, Xtool engravers for schools, people who want to do after school, summer camps, and also for people at home too. So we've been helping also in the homeschool space as well. So again, we're the educational partner for both MakeBlock, who provides robotics, and Xtool, who provides a laser cutter and engraver. So they are one of the largest providers in the world, based in China, and we are the U.S. educational partner for that. So we offer cutting edge technology. So we're very excited about that. We have 9 different robots, both Lego robots and, robots for little ones like M Tiny, all the way up to robots like the ultimate robot for middle school, high school, colleges. And so we can schedule a Zoom call, tell you about all those different robots, different options, find the one that's best for your students. We also offer, like I say, comprehensive learning solutions. So we provide video curriculum, lesson plans, grading rubrics, things like that. We can tailor it to your needs and budget as far as what you need for that. And, we specialize in hands-on opportunities. So that is our goal, is at every lesson, the kids will work with robots. At the end of the lesson, robots or cut things out of the laser cutter engravers. At the end of each lesson, they actually see their things work. They'll have fun with jousting or BattleBot, or in this case, we're combining robotics with something cut out of the laser cutter and engraver. We also have a supportive community where we have teachers working together, sharing ideas, things like that. We always are updating our curriculum with new videos and stuff like that. That's the beauty of online, right? We can just keep increasing what we're providing for you as we are working with the curriculum and working with our teachers and finding out new things that we can do with our robots. So there's also a commitment to innovation. So Xtool and MakeBlock, they're always coming out with next laser cutters and engravers. As you've seen with Xtool, they just came out with the F1 Ultra, M1 Ultra. So Ed will be talking to you about that. But just always something new to keep us innovative. And same with MakeBlock. And like I said, we then come up with Lego robotics as well with the MakeBlock robots. We do, as an educational partner, Robot Academy offers 8% off of any prices you find from the Xtool, MakeBlock, or Amazon websites. So just let us know. We give you a quote for that. We offer priority support. So if you have any problems, contact us first. We've normally encountered like whatever your question is or something, and we can help you also be efficient in your school, your classroom. So we have lots of classroom tips for that. But any problems, we can often just give you advice, help you fix it right then. If not, then we connect you with support, email, and then they answer us within 12 hours. So we are priority support with that because we're the educational partner. We do offer, what's different with if you buy from Robot Academy directly, is we can offer you professional development if you're having robotics in your classroom, or we offer a coaching call, we call it, with Xtool. We recommend you set up your machine first and then work with Ed and a coaching call. And it's been really effective to just, help you through any gotchas so that you're being effective, and creating really cool things right away. So anyway, and another key thing is that we ship a lot of our laser cutters, engravers, and robotics straight out of the California warehouse. So real quick shipment, you receive it within a week. That's what a lot of people are asking, so it is quick shipment from California. We're based in Ohio. We also have offices in Orlando, Florida, 2 offices in Ohio. So it's either coming out of Ohio or California. So real quick shipment for that. So today, what we're going to do, we've had a lot of people join us. We're so excited. So we have a lot of people who have joined us. So just a little housekeeping. So for questions and answers, if you're having any problems, just message me in the chat. Feel free to, I love the thumbs up. Feel free to do some smiley faces and stuff like that. Questions for Ed then. You want to directly do the chat to Robot Academy Ed. So that will be questions that he can answer for the whole webinar. And as far as what we'll be doing today, I'm just going to cover the concept of smart fabrication, what that is, and how that is really awesome in the STEAM education environment, especially. Some of the tools that we're using for the smart fabrication, information about some of our latest X tool laser cutters and engravers, and then he'll do the project, the step-by-step creating of the robotic safe. So that's what we're going to cover today in 1 hour. And now I'm going to introduce you to Ed Vaughter. He is going to be telling you about X-Tool. He's our X-Tool expert. He's been working for 20 years in the IT and robotics space. He is a graduate from Ohio University and computer science and degree, and has been a director of a Fortune 500 company for many years, and also has experience with coaching a winning robotics team. So that's how he's gotten his start in helping our students with robotics. So here's Ed.
All right. Thanks, Gail. Thanks for the intro. I think I fixed the chat, folks. So thanks I think our first winner can probably put the chat in there directly to the Robot Academy user, which is Gail. And I'm not going to spend a lot of time on camera with you. I've got a couple slides we're going to go through because we want to spend most of the time doing the project where we're going to integrate some of the things Gail talked about, why to use laser cutters in your classroom. Many of you, well, some of you we know personally and already have some laser cutters and looking for projects and ways to extend the use of them. So that's what this STEAM on Board project series is about. Here's our general website and our general email address for your information. I'm going to go press on there. So why do we want to talk about laser cutting as it relates to it? I mean, maybe the last generation of this was we all integrated 3D printing into the classroom, and there's a lot of similarities there. One is hands-on learning. You'll get to see that through the project we're going to do, where there's hands-on mechanical construction. I think that's really important because I think that's really lacking, especially in recent years where people have been out of the classroom a lot and virtual a lot, and kids relate to the world through an iPad, and it's important for them to touch and build. We have project-based learning. You'll see how even this project we're doing today is very extensive. You can make it go much deeper if you choose to, and we're going to give you some peeks into that. Improve student engagement. It's very multidisciplinary in terms of all the different aspects of coding, analyzing, designing, problem solving, and we really let them be creative because they can modify these projects, and so can you. So it encourages computer literacy because they're not just clicking through things. They're actually going to learn to do design tools in the MakeBlock software called Excel Creative Space. We're going to look at that, give you the design file to get started, and they can obviously change that. They're going to learn to code. They can get creative and be artistic in the things that they create and feel more engaged. They're not just replicating something or doing the building blocks. They can modify it and make it theirs. And I think that's what's neat. We see little middle schoolers learn to code in the block mode and know that they can make the robot do something different. And this last point, as I really love, is they're not just consumers of technology or slides or whatever. They're becoming creators in their own right. So what else does laser cutting bring to schools? It allows you possibly to create classroom resources. You can create through cutting, engraving, different materials. A lot of times it's wood we're going to do today, acrylic, and engraving, a lot of different things. You can make tools for the classroom. I'm going to show you a couple that we use in our camps and after schools that we created to help us create something else. Create resources for the students, supplement lessons various ways. It's a lot faster than 3D printing in terms of making widgets. Obviously, it's not exactly the same, but we can create things more quickly. It's great for prototyping, especially if you need one-off parts and if each student is doing something unique. All right. So I want to highlight a couple of things that are a little bit newer. A lot of you have laser cutters, But a couple of things that are new, Xtool keeps enhancing these things. Autofocus is one really cool thing. The machine, many of them have cameras to help you focus. So the days of measuring with a ruler, the distance between the laser head and the material are over. This picture on the left is showing batch processing. This type of batch processing where it finds the material, but even more exciting, this bit at the bottom where the bulk production is now possible. A lot of these products have conveyor systems to automate, and you can do more if you need to batch create something for a project. And another example is curved surfaces. You can plot the chaining focal length, a curved surface. So there's just a couple of highlights. Here's some quick examples for different disciplines. These are some manipulables for math you could create in a classroom. This next one is science-related examples. This is kind of where we're going to fall today with our project about the safe. There's really cool, obviously some robotics there with the grabber. And then this one on the left is interesting. It's a greenhouse where it's the same controller we're going to use, the CyberPi. And in this example, it uses humidity and temperature sensors to adjust the lighting of the greenhouse. So you can integrate all kinds of different concepts. Like today, we're going to integrate some security concepts. Could be social studies and history. You could use these tools for. Here's design and entrepreneurship. You can, a lot of times, school items can be made for sale. So a lot of times DECA clubs will use it. And even in pure art, in terms of art and design, it can be used in those classrooms as well. So what are we going to focus on? We are going to talk now about the tools that we're going to use today. I'm going to try not to spend too much time on the actual models because there are many different models. One of the things we do in coaching calls, pre-sales calls, is to help you pick out the right model. It has a lot to do with what materials you are interested in using, as all the lasers have different capabilities and limitations. This is a workhorse that's been around for years. We have one of these, and we cut the wood for the project today on our M1. It's a 10-watt diode laser. Really great for all these different kind of materials. Very fine engraving, very tiny laser dot, and can cut 8mm basswood. We just cut 3mm for this project. Works with all the rotary tools and other things that Xtool provides. We also have an Xtool P2, which is a larger format device. It's a CO2 laser. It's excellent at cutting glass. It can cut much thicker wood and acrylic, and can cut clear acrylic items, which is unique, and much larger bed size. You can see the size down there. So some people need that. It's a much larger device. You need a bigger lab for that, a bigger table service for that. The one we're going to show today in the webinar is the F1. It's a portable dual laser, which is diode laser and infrared laser. This allows it to cut a lot of different materials. You'll see here in the right side of the screen, two powerful lasers, infrared laser for metals and plastics, and then the same diode laser that I mentioned in the M1. But it's a little bit faster because of the logic that was built into this unit. It's quite a bit faster. You're going to see some of that in action as we move forward. So we're also going to use the CyberPi, the little control that we mentioned. This is a single board computer with a joystick control, button controls. It interfaces with lots of different sensors, temperature sensors, humidity sensors, buttons, servos. It has Wi-Fi, it has Bluetooth, so it's networkable. We have lots of different materials in terms of doing electronic product design, game design, because it's networkable. It's just kind of open-ended what you can do with it, and we're going to show you. This happens to be this is block programming or Python programming, by the way. This is the same controller that's part of the MBOT 2 product. You'll see it just clips right on top. And so it's very extensible in that regard. So whatever your students learn in terms of the CyberPi and the coding goes right on through the robot product line. And the MBlock 5, which is the programming environment that we're going to show, is block-based, but also can be used for Python. So again, get simple, get the kids to understand basic programming, and you can move them on it to advanced higher grades.
Yeah.
So this is the project. It comes with the CyberPi. It comes with what's called the Pocket Shield, which is, you'll see it's the one with the add-ons for connecting to all the sensors. So this is an example where we're going to include mechanical fabrication and construction and digital security concepts about passwords and also coding. So part one, we're going to build the box, and then we're going to do a password protected safe. This is what's in the lesson plan, these 4 parts. We're not going to do all of this today, but we're going to hit on the password protected safe. We're going to build the box. I already have one built for you, but we're going to look at some of the difficulties of building it. And I will show you the lesson plan as well as we move forward. So let me show you where we start. Actually, I think I'll show you the lesson plan right now. All right. So this is an example. This is included in the project. And this is part 3, part we are going to get to in a little bit. It just shows you that this is really set up for educators, giving you objectives, giving you timelines. It says this is for 11 and up. I think this could go much younger than that. It really depends on your classroom style and population. Tells you everything you need for it, gives you suggestions on how to engage and explore more deeply, gives you the code related to it and walks through the code, gives you suggestions and hints, and then also gives you ways to evaluate and exchange and make things better. So each one of these 4 steps has that. That is what we're going to do. So let me move forward. So at first we're going to do, you have to create the project. You have to create the pieces. And what this is a kind of a recorded version of what I did to create the one I made for you, but we're going to walk through it interactively as well. But the design is provided. The design is a design file, like a CAD file, AutoCAD file that I imported. And you'll see it's this grid in the background is the M1 cuttable work area. Okay. So clearly that doesn't fit the M1 area. Now it might fit the P2's work area, but we are using the M1. So when I get this file, then what I want to do is I decided to cut it on 2 boards. If you're cutting it on smaller boards, you might need 3 boards. But I cut it on 2 boards, and I'll show you that in a minute. I think I'm just going to turn my video off so you get even more screen space. And okay, so what I do is I save as, and I saved as Safe Box Sheet 1 by just deleting the things on the right that didn't fit. Then I magically rearrange them. Look how fast I did that. Yeah, I rearranged them so they fit on the board that I'm using. And with the M1, this model has a camera in it, so I can actually see the product. So in this next screenshot, you're going to see there's my board that I cut. This is actually an A4 board, A size board. And I can actually lay that out. You'll see I actually had to flip a few things around to get it to fit, right? You can pack things tighter if you want to. This is showing a really cool feature. What you're seeing in the background there, if I zoom that in, you'll see that's actually the honeycomb panel that when you're cutting wood and acrylic, you want to get good airflow. So models you'll either buy the honeycomb add-on. It's included in most bundles, especially educational bundles. And that's what that frame around it is. Some of the models have ribs in the machine, so you don't need the honeycomb panel necessarily, but that's what you're seeing there. So then I divided it up. I also then took these are the ones I deleted. I saved that as sheet 2. You'll see I made sure that fit. There it is in the honeycomb. And then cut all those out. All right, so I'm now going to show you a little bit an updated kind of live version of the using Xtool Creative Space, just because I wanted you to see it a little bit more details about it. Excuse me one second. And so here is that just a blank workspace. This software is very well done. This is the current production version. There is a beta version out that supports the new ultra versions of the F1 and M1. I am just using the general release version. So if it looks different than yours, it's just because I haven't put the beta on. Didn't want to show you the beta yet. I'm going to open and show you how I did that. So I'm going to go and grab the CAD file. I'm just going to import an image. And when I do that, the CAD file is called a DXF file. The exchange format. I'm going to open that up. And you'll see it's going to open up. It's going to ask me, do I want to scale it? Many, many times you would want to scale it. Okay, because you have the machine you have, you want to work within its capabilities. In this case, I want to display it in the original size because I'm following a project plan, right? If I let it scale it, the CyberPi wouldn't fit into the pieces that we cut. All right, so I'm going to say no, keep it as original size. Everything comes in as selected, so I'm just going to click away on the canvas somewhere to unselect everything. And you'll see here how, I would have to rearrange things because I can't cut this on this device. This knows that I was connected to an M1 here. This is live software. This is not screenshots. And I would come over here and, rubber band, select all those and delete them. Now I always, you always want to do your save as first. So you go file, save as panel 1, file, save as panel 2. I always recommend doing all your saves, save as panel 3, so you don't mess anything up. And then reopen those individual panels and rearrange them. So I'll go ahead and open one of those that I already have done. I'm going to not save that project. And you'll see I've already done sheet 1. Now you'll see that this is my rearranged sheet 1, and I can cut this. And I cut one to make the project for you, and I have a spare set to show you. And here you'll see some of the basic settings up here is that we're doing laser flat on the bottom of the machine, but all these machines have different modes and can do cylindrical, open plane, which means going through. I'll show you that with the F1. We have the material selected. I would say when you're first starting, it's really good to use standard materials, meaning Xtool materials, because they're all listed specifically in here. And then the height measurement. The devices, all the models have slightly different versions of how they measure thickness, but it's all gotten away from the old manual measurement. This automatically measures using a laser light to the top of the material. And in this case, you'll see it's 2.6 millimeters, even though I'm cutting 3 millimeter basswood. Well, why is that? Well, in this model, I have to take the bottom tray out to put the honeycomb in. So it's actually slightly lower to work with this model. So I leave the bottom open. I actually usually use it with the riser base. You'll probably almost always want the riser base when you buy, so that you can do thicker objects, taller objects, and do rotary objects like tumblers and other art objects. So this I would click and automatically measure it. You can also manually do it, but you'll notice it doesn't say anything about the power or the thickness. So let me zoom back out. And I said zoom back out. And you'll notice it's because I don't have any object selected. Once I select this object, now I'll see that I have it set to cut, power 100, and a speed of 4. The defaults are 5. I just found that with the wood I was using, maybe it was a little more humid or something. It's still summer-ish here, and wood is very affected by temperature and humidity. So I slowed it down a little bit to make sure I got it clean cut. And Gail, I hope if you're watching for any questions about this as we go through, that'd be great. Thanks. So one of the biggest things I want to point out here is that
Ed, one thing Trina just mentioned, she sees a lot of math integrated into this project. Did you want to talk a little bit about the math for students?
So there's definitely some computer science stuff integrated in. I'm not sure what she means by math. Maybe you could clarify
Okay.
in your question, please, because in this case, the measurements are all done. The wood of the measurements all done for you. So I'm just focusing on right now on the manufacturing part, the fabrication part. But in the coding, there's lots of math that you can bring into it, and we'll try to touch on that a little bit later.
Okay, with the CyberPi.
Yeah, when we get into the M block. Okay.
Okay.
So one of the common things I see people, especially when they first get their first laser, is you'll see that when I don't have something selected, I see the product. I see the wood, okay? If I changed it to something else, it would change all the settings. So let's say I was going to do this on metal. That would be crazy. It's going to change the thickness to the defaults. But it also is going to change the settings. It's going to change some of the settings of what it thinks I need to do that on a metal card, okay? I'm going to change it back to 3mm basswood. And you'll see it still has my modified, it's changed everything back to power 5, which is the default setting. I mean, the speed of 5, I'm sorry. But one of the common things that happens is like when I opened up that project file, I'm going to say no. I'm going to go back and import that file one more time, that design file, just to highlight something to save you some runaround maybe. So I want to import that. Everything comes in without power settings. So even if once I click 3mm basswood, okay, it did set, but you see it's not set right. It's set to score. So you have to just remember to manually set everything. The other thing is if you have multiple devices, or for example, if I send you this file, we're working together in this project, and I send you this Xtool M1 version of the file, as soon as you change it to your P2 model that you have, it's going to change all the settings it's going to change them all to 0 power or 1 power. Okay. And what you'll do is you'll run it and you won't get anything. And it'll be a mystery of what's going on. So in most cases, what you're going to do is highlight everything and change it. So in this case, I'm going to pretend I can burn all this because we've already talked about how to split this up into multiple boards. I'm going to highlight everything using Control A, and I'm going to change it all to cut. Okay. And I'm going to manually set everything to 100% power. And I'm going to change my speed to 4. You can manually type those things over there instead of using the sliders. If I was cutting thicker wood, or harder wood, say walnut, or again, I just happen to have it's humid in the workshop. For some reason, the air conditioning's down. I might even run 2 passes on this, and it'll go over each cut twice to make sure it gets through the material. So you're always going to have to experiment if you're using your own materials. And again, that's why it's nice to start, especially when you're first getting started or doing a project like this, that you go with these standard materials so that you don't have to fiddle around as much, because you're going to have pretty good settings by using these standard settings. All right. So that is what I wanted to show you there. And I want to minimize that, because we're going to press on here. All right. So here's our pre-made one that I'm showing you, kind of a close-up camera. I use this document camera a lot to give you a close-up view of things. So this is the pre-made one. And you can see the CyberPi there. This is on the front. It's connected to what they call the pocket shield. And there you can see it's powered on. There's where all the sensors connect, servos connect. I've got the servo, which is in the door hinge, wired in through the door. Okay. And what we're going to do is make one of these. If you're the winner, you get this all pre-cut and it'll all come and be really easy to do. All right. I'm going to demo it well, we're going to build it first before we demo it. See if I can. I'm going to restart it actually. And this is the simplest one that we're going to do, where it just says it makes one button open, one button close. So if I open this, click the open button, it sets the angle on the servo. And then if I click the close button, which spin this so you can see it, close button down there, it's going to slam the door shut. And you'll see inside there's a shelf in there, which is kind of cool. Kids would love hiding their candy or whatever, the cell phones or whatever in there. So I'm going to close that, and we're going to get into some details. So, and Gail, if you break in whenever you think is a good breaking point, if you want to do another giveaway.
Okay, we have a few more minutes.
Yeah, probably a few more minutes. I just want to say there's not a real breaking point in here. So, So this is the first part. And again, this all comes in that PDF that I showed you earlier, where I showed you the lesson plan. It gives you step-by-step instructions on this, and it shows you exactly what pieces and parts to pull out. So the first one thing I noticed during this that I could save you some time on is that there's a little bit of a flaw in the instructions. And what I found this when I after I already glued it and put it together, is that these parts should probably be reversed. And I'll show you why. So basically, the kids will learn great construction things as well, because this is a very simple slot technique, okay, where these fit together. You'll see it fits a little loosely. That's based on just the cut quality that I got. It could be designed to be a little tighter if you wanted, or you would just glue this. So in some of the key joints, this is going to be tight together, so I didn't have to glue it. I want to show you one other project that we did on Steam on Board last year, and that we love to show when we're at trade shows and school fairs and things like that, is candy machine project. And this is another great STEM project. So sorry, it's a little close there, but it's a chimney. It was originally a Christmas type project. So it's a chimney. And what it does is, there's a Cyber Pie on the front. What you do is you load the chimney with candy, and there's an ultrasonic sensor inside. And when someone puts their hand in the fireplace, it's not turned on right now. When someone puts their hand in the fireplace, the ultrasonic sensor sees their hand, opens the servo, gives them a piece of candy. Everyone laughs and is excited. And then it does things on the screen, tell them congrats on getting a piece of candy. So this is showing a slightly different type of construction, where the tabs are a little bit longer. And again, these are just things you can integrate in. You see the tabs are a little bit longer, and they have a little kerf on them. And then they're held together by a rubber band. I'm going to take one of the rubber bands off, and you can actually see it where it's got a little slot. See that? And the rubber band holds that piece on to hold the whole guy together. All right. So that's one way some of the products are made. There's some nuts and bolts and things involved. The Cyber Pie here clicks on with a little thing, almost like a Lego Technics connector, that clicks just into a correctly sized hole. And anyway, that's just a great other fun project that we had. Okay, back to our current project. So this, you'll see the back of the door is this square part, this rectangle here. And the diagram shows us to do it this way. And then you'll see that we're going through two pieces of wood on the bottom here, if you can see that. Okay. And then this is the front piece that you see matching what I did there. All right. And the instructions, and you'll see here, see how the one slot, the notch, if you will, is twice as long. One's 6 millimeters long on the top, I'm showing you. So that's to go through the double thickness. All right. So I'm going to put that on the double thickness. Well, what I discovered here is that it really should have been switched around. So I'm going to have the instructions show you to use these three pieces with those slots all lined up like that. But after I put it together, if you look up here, it's blocked out because this long piece is at the top. All right. So I can't get to the on and off switch on the Cyber Pie Pocket Shield. So I had already glued it when I noticed that. So this Cyber Pie has been powered on for several days. And I just plug it in to recharge it. So we're going to flip it. So yours would be done differently. We're just going to flip each of these pieces that we cut for this door. We're just going to flip them 180 degrees before we put it together. Okay. And then this double slot piece goes down below. Hold that in there. Put this piece in here. And that hole there is for this screw where we would hold a Cyber Pie on. So we're going to flip this piece too. And this goes on. Now this, I did have to put a spot of glue, just non-toxic wood glue on all these to kind of hold this together. The screw for the Cyber Pie holds in it. So I would have set the Cyber Pie in there before putting this top piece on, obviously, and screwed it down with the screw. It tells you exactly what screws you need. You're going to want to have some M4 screws in stock, which is usually what these products ask for. Varying least, if you have M4 15 millimeters and M4 25 millimeters, you're pretty much set. The product says 30 millimeters, but you don't really need them. So that's the basic thing there. We would screw that together. These holes here on the door are to help you get to the screws as you're screwing the servo on. That makes sense. That's why those holes are there. The servo screws on here. It's easier to screw the servo on first, I thought, so you don't really need these holes on top, but that's why the designers put that in. And so you create this little sandwich. You're going to attach it to the servo. And for the servo bits, you'll see little spacers like this. This little guy is just to sit on the servo to space it out correctly. And there's a couple screws that we would need to hook that on. And we would hook it onto the front of the unit. So again, now you can see we're going to hook that door on. And I'm not going to actually go through all this because I would have to glue it. And I don't want to kind of waste you guys' time doing that. I hope I'm showing you enough details to help you get this done. So you're going to put this together. You'll have the servo on there. And then that's now one unit. All right. The other bit of the box is pretty straightforward. I'll give you a couple of hints on that. Is that the box, I'm kind of showing you now down the front. This is if the front is off the safe. Basically, I put this together with the rubber band just to test fit it and show it to you. And you'll see that the shelf, that's the shelf inside the safe, has a clean front edge. So that's one of the clues, which part is which. And again, the drawings are all in the teacher's guide. And then these pieces on the side, they're the only other pieces with clean cuts. Okay, no notches. All right. And it all fits together nicely. There's a gap here at the front of the shelf. So the shelf is in the back of the safe, just like it should be. And that's it. So I probably would glue this together first. I did on with the one I put together completely. I would put the whole box together and then just lift it up. So you just lift this up, put a drop of glue in each one of those. All right. And that's it. And the other pieces, obviously the top and bottom, go on the same way. They're a mirror image of each other. And then the little corner pieces, you definitely have to glue because they just won't hold on with just the notches. So they go in the corner like that. All right. So it's not designed to be, some super sturdy item. It's designed to be something fun and that you can teach to. So there we go. That might be a good time. I'm going to jump into the code related to this. And so this might be a good time to, Gail, if you want to do a drawing. Do we have 2 more drawings left?
Yep. We have 2 more drawings
left.
All
right, we're at 145. So yeah, I want to spend some time in the code and I want to show you the F1. So I hope this is helpful. What I want to show you now is the code. And so this code also comes with it. So these files are included with the project. And I've already opened this one that is running right now. So if I flip back and show you, right now we have a very simple version, which is just saying open and close. All right. Obviously not super secure, but it's just, this may be the first program that the student has ever done. So I'm just going to show you this briefly. I'm going to zoom in there for you. And you'll see it creates a forever loop here. When CyberPi starts up, it sets the angle of the servo to 80, which is tighter than 90 in this example, the way it's constructed. So it has it very tight. And then it does a forever loop and it shows, it flashes that open on the right hand corner. There's various ways of addressing the screen. You can address it actually pixel by pixel if you like. This is a simpler way to do it. And we're going to say, throw the word open with an arrow at the upper right corner and make it big. We're going to wait a second. Then we're going to show close and we're going to loop forever on that. And only shows it and you'll see it's flashing. So it's the defaults are to clear and then go. And then all we do is say when button A is pressed, it sets the servo angle to 160, which opens it wide open. And then when they press the B button, which is the bottom button, the angle button, it's going to reset that servo angle and you slam the door shut. So I already showed you that earlier, I think, of how it opens and slams the door. So I won't show you that one just now. But what I want to show you is next up advanced version of it is that I'm going to open a different version of that up. Okay, the default, is cloud storage available with this. Cloud storage is not required with any of the MakeBlock or Xtool products. I just clicked on the wrong one, open from my computer, and I'm not going to save that. And I'm going to go with the one that says password. Now, there are other more complicated versions that are in the teacher's guide, like live mode. You can actually work with this device live connected to the computer, so you can have people type a password in the computer. You could network it using a remote control. You could get really creative with how you wanted to extend this project. But I'm going to go with password unlock, and can't really zoom this one in for you. Yeah, I can. All right. So what this is going to say is, okay, we're going to do a forever loop. We make sure the door is closed. And then we show, please enter your password. And we're going to download this to the CyberPi in a moment. And now in this forever loop, it basically waits until they pull. So again, this isn't super secure. The password here is in the code. Okay. But again, the password is using the joystick up, down, left, right. So that's our password, up, down, left, right. Kind of like doing a touch pattern on your smartphone idea. You draw a pattern on your smartphone. So the kids will be able to relate to that. So we wait, and if it's pulled, then we print the up button, okay, to show that piece has been satisfied. All right. And when we do, we change the angle to 160 to pop that door open. And when they press the A button, we slam the door shut. All right. So I'm going to go download that program to the device. So let me flip over here. I'm going to show you. The CyberPi has a USB-C port for charging and downloading. All right. And I'm going to connect. I'm going to connect to this device that I just plugged in. It recognizes the COM port pretty reliably. And then I'm going to upload this program. Here's the live mode I mentioned. I could actually interface with this live if I wanted to use the computer to provide input. And one of the lessons does go that deep. I'm not going to do live. I'm going to do upload and upload this program. All right, there it is. It's uploading. And then what's going to happen is the CyberPi is going to reboot. And rebooted that fast. And now it says, please enter the password. So I know that text is a little blurry, but it looks fine by the naked eye. It just looks a little funny on the document camera. So now we know the password is up, down, left, right. So when I press up, it shows that I satisfy. If I keep pressing up, it doesn't work. It doesn't do anything. I'm going to press down. I'm going to press left, and I'm going to press right and hold the thing still because it's going to fly the door open. Now, I probably should have taken that cable off before I did that. And now I can press the button to close it, and it slams the door shut. And it just loops, and it loops and does that. So up, down, left, right, open, and then hit the B button, and close it. All right. And I accidentally hit the back button when I was holding this. That's why the program's not displayed. If I go to the back program, I can switch buttons. I can restart it. If I restart it, it'll go right back into that program. Enter the password. So you see how fast that thing reboots. So that's kind of cool. I wanted to show you back to the PDF because one of the things, where is that PDF? A next advanced topic that would be more secure, obviously, is to use a real password. And this is, again, all in the materials. The code is provided. And this is an example of using an array. And this version of the program would be something akin to texting on a flip phone, if anybody remembers that. And to get the letter A, you have, maybe to get the letter C, you got to press the button 3 times. So they would create an array of letters, and then it would loop, and they would use the joystick like a cursor, and they'd go up, 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 up to get D, and they would press the joystick button to enter D. And then they'd go up, up to get B, press enter. And they would enter the password. The password here is in the code that I'll show you below. And now this is showing them indexing into the array. So that was the array. I jumped ahead a little bit. That's just showing how they would load the array. I'm not going to get into the details, but it's all laid out exactly here. And then they use how many times they've hit the joystick to go down into the array, and then grab that letter, add the item of counter of letters to the password input. So using the counter of how many times the joystick has been hit to pull the B or the C or the D out of the array, stick it in password input. And then when they press the button, it reads the password input. In this case, the password is just AB. If they enter AB, it'll flop the door open. So I think it's pretty good. I just wanted to show you that, to show you how advanced you can take it. Again, this is computer science. This is teaching them more advanced programming concepts, I think, in a pretty fun and engaging way. Any questions about the project?
Anyone want to put a question in chat if they have any questions about the project?
Okay. So I got the F1 sitting here too. And I want to show you this because, I didn't get to show you something I forgot to show you earlier. I'm sorry. I talked about making things to help you make things. And one of the things we use is we give out a lot of BattleBot awards. And here's an example. First place BattleBot winner. You can see there. Actually, you can't. We give away these metal dog tags as participation kind of prizes within our BattleBot events and day camps. And this is engraved normally on the M1 because we can do a big batch of them at a time. So what we did was we made a template. This is an example of the template. So this is a 7x7 grid, and we load it. We loaded with while the laser's cutting another batch. We can load this up with the colors we want and have it all ready to go. The reason it's curved to the top is because we can also do round versions of these tags as well in using the same template. So this is something that we had, that we designed just to help us to fabricate these tags in a faster way. We also can do it with the F1 that I'm showing you. Is that we can, in this example, I'm just doing one tag. We use it at trade shows and we do 3 at a time. But you'll see there, I told you the M1 had a manual measuring, automatic measuring. This has somewhat of a manual. I just align those 2 laser dots that you see there. And when I've got those aligned, then the measurement's good enough. And the software has lots of great ways to help you.
We have a couple of questions.
Couple questions? Okay.
While you're
I'm going
doing
to open up a
that,
quick project. Okay.
they're asking about the file for the dog tag jig. And
okay.
also, just these resources in general, that we're showing them today, how can they get that? And can this be done offline? So that's a couple of the questions.
Can it be done offline? So can it be done offline? Yeah, this is all, I'm not using really the internet involved in any of this. And I know that question comes up because some product lines out there require you to have a cloud account and pay monthly fees and stuff. And MakeBlock Expo does not do that. You can use the cloud storage to save things. Most of us already have that. Your school already has OneDrive or Google Drive or something like that. There's no reason to have another one, I don't think, but it's there if you need it. I save everything locally in my OneDrive, which is on my laptop essentially, and save it from there. So yeah, no cloud connectivity is really required to do any of this. I hope that was the intent of your question. I want to show you. So this is what we did you'll see a dog tag that we produced. I'm just going to create one. I want to show you real quick how some of the advanced features is that I'm going to turn on the framing feature. And now when I flip back over to the camera view, if I switch back over to the camera view, you'll see it tracing. And this is just a safe blue laser tracing so that I know that it's aligned correctly. And these kind of features are just very well thought out to help these things be fast. I'm going to go ahead and process that. And just to show you what that looks like while we're finishing. This is the portable F1 that we talked about.
We also have the F1 Ultra.
Yeah.
So the difference
and we're gonna put a link in the chat. Well, the F1 Ultra is more powerful. It's quite a bit more expensive, but it is more powerful because it has a fiber doped laser, which really ramps up the power.
Okay.
This standard F1 is very, very versatile though with the materials it can use. And we don't have to wait and watch this, but we are going to put in the chat and we'll include it in a follow-up email. People asked about the resources. We can provide these things and in a follow-up email. So if you got the confirmation emails, then we know your email works and we can send those things to you. We're also going to send a follow-up link to get your feedback on the training quality and content. And also there is a trial where we have a trial there that took 1 minute to do that. I'm going to switch back to my camera view.
You have a trial of the F1.
A trial of the F1. So that is an application that you can click on and we'll have a follow-up conversation about that because obviously there's deposit involved and shipping and all that stuff. But if you want to get your hands on this to really put it through its paces to see if it works, we have, I think someone even who's on the webinar right now who has these in their STEM buses. Because it's portable, it's very easy to move around. It's very lightweight. There's a handle on the top you can see. Let me just show you this real quick, what we did. That was 1 minute to burn that. It's a combination of vector text and a bitmap image of our QR code. You can actually scan that QR code and get to all the resources that we have about the products and the services that we offer.
So if they're interested in a trial, they can just email me, right? Is that?
Yeah, that'd be great.
I'm just going to put that in chat.
Yeah.
For everyone, so they can email, and we will have an email follow-up with the resources for this project. But someone asked about the jig, that dog tag jig. That's part of our classroom set when you buy the one of the machines from us, the M1, P2, all those. We have the jig for several different
common
projects.
Items, keychains, different common things. So
dog tags, yes. So we have more information on that at robot-academy.com if you look at the classroom sets for the different machines. Again, I'm Gail with Robot Academy. That's our information right there. So if you have any questions, follow-up questions, or if you want to jump on a Zoom call, we can show you more about how to use Xtool and MakeBlock robots in the classroom. And then we create our own Robot Academy Arduino Lego robots And we have different add-ons for the MBOT 2 to make that into a Lego robot as well, so that you can add that whole dimension of mechanical design.
Mm-hmm.
Sound good?
Yeah.
Any last
Yeah, I
points,
see
Ed?
there are a couple follow-up questions,
Oh,
and I think because of the time, we'll just follow up with people individually about those questions since we're out of time. And appreciate everyone being here. There's that QR code on the screen if you want to get to our webpage that has all various materials that if you had been in person or met us at a show or a seminar, you would have gotten access to all those documents. So they're all there for you. Thanks everybody for being here.
thank you. Take care.